Hello everyone, and we are wrapping up the egg experiment. It is day 4. So on your sheet should be looking somewhat like this along with mine. I did realize we forgot to write something from yesterday, so we're going to write that in just a bit. But just a reminder, I only need this filled out once. So if you follow along with me day by day, you're good to go. If you follow along and did your own data, awesome. If you follow, or if you decide to wait until Thursday and then you're using the slides, fantastic. Just need this done once. It's due by Tuesday, which is the 26th. So let's dive into the egg experiment. Hopefully I don't make this too much longer yesterday. I think it was still kind of long, even though I tried not to make it long. There's just so many cool things. It's science. But let's get going. And we'll get the backside done here too today. So first and foremost, we need to put our date today. And today is the 21st. What we forgot to do yesterday is, remember, we put our egg in corn syrup. I mentioned it a number of times, but we just forgot to write it in. So make sure you write that in if you haven't already. Now, what we're going to be doing today is, first and foremost, we need to look at our egg. So when we look at our egg, you'll hopefully notice there's like water at the top. If we do kind of a side view here, do you see like it's like water and then there's like corn syrup? So what happened? We can also see our egg kind of looks deflated, almost like it's gotten broken, which it hasn't. It shouldn't have, at least. So what's happened? Let's go ahead and take this out. We'll put it gently. So this is another, gently, be careful. Something I do have is I do have a plate, because I'm going to put my egg on a plate, because, if we're going science here, we're definitely cutting this egg open in just a bit. Now, when you do rinse it out, just be careful, because you want to get your egg and you want to get rid of this other stuff. But you'll notice as you pour it out, remember the corn syrup yesterday was super thick? This is not thick. This almost looks like water, because it kind of is. So usually what I do is I kind of try and get that stuff out, and then you just got to be really careful. Sometimes I try and dilute out some of this corn syrup. This egg's kind of going to be disgusting today, I'll tell you that. So if you want to try and rinse off the egg, just make sure you're not using a lot of water so that you don't break it open. And I'm going to take that and set it over here. And honestly, you got corn syrup in the sink. Your parents will probably appreciate if you rinse that out. It's not just a hunk in there. And then if you've used a cup, that is one of your cups at home, well, rinse it out. If it's not a cup, if it's one that you can throw away or recycle, throw away or recycle it. So what we're going to do here is, let's take a look at our egg. So we have the looks like, feels like, anything else. So when we look at it, it is very deflated. It's still purple, right? Or whatever color you colored yours, but it's very deflated. It still kind of has its egg shape, because remember, that's the membrane of the egg. So it's still going to keep kind of its shape, but more so it's deflated. And if you look, see, some of the shell is still kind of sort of still coming off, just a little bit that is left over. Now, things that it might feel like, so it feels very deflated. It's not like taut like yesterday. It was like very tight, very taut, like you could squish it, but it was like a basketball that has air in it, and now it doesn't. You might notice that the membrane almost feels like paper, kind of, sort of, which is kind of weird. But what's happening there is, so remember when we had all that water going into the egg, because the egg was what was more concentrated compared to the vinegar, compared to the water. So water was passing into the egg, and it was trying to reach equilibrium by dissolving the inside of the egg, or passing water in. Now the water's all been passed, or it's not all, but it's been trying to get passed out, and because it's trying to pass out, there's not extra water like in that membrane. So we just get this kind of papery, thinned out So for the anything else, this is Oh, before I go too far, we need to weigh our egg because we want to make sure we get that before we open it up. So let's go ahead. So we're going to zero our scale. And we'll write down all of our observations here in just a minute. So I'm going to put my plate on my scale and then zero it out. Okay, and then add the egg. So it's 46.5 grams. And since we're done for a little bit, I'm going to pick up my pencil. I'm going to wash my hands here a little bit quick. And then we can write down some observations. We can write down some notes. All the stuff. So let's do that. So our current egg mass is 46.5 grams. So we can add that. What does it look like? It's deflated. It's purple still. Something I always notice is there's like dark spots, kind of maybe where the membrane's thin or thinner, or where like all of the eggshell, if there's any left over. If yours isn't purple, don't put purple, put whatever color yours is. Something it feels like, it's almost like papery. I don't know if that's really a word, but we're going to make it a word. Papery. And it looks like we could still say it's egg-shaped, like the outside. I know, getting out the white out. Like the outside layer. Like that outside layer, it's still more or less egg-shaped, it's just deflated. It feels papery, very squishy. Feels like it's maybe missing its inside. And then in the anything else, we're going to cut this egg open and see what it looks like inside. Let's do a little bit of math here. So has it gained or lost how many grams from day 3? So we're just going to go back to day 3, which was 82 grams. And then today it was 46.5. So 82 minus 46.5 gives us 35.5 grams. And we can talk about, we're going to open up the egg first before we talk about the Y and then move to the back. So this is the part where everyone's like, can we like cut the egg open and see what's inside? Of course, we're scientists. We want to see what's inside. We've got all the data we need, or at least while the egg is whole. Now we want to see the anything else. Let's see what's inside. Please be careful if you're I'm using a butter knife. You still could hurt yourself, so please be careful. Usually what I do is I try and just like pinch a little bit and then just slit it just a little bit. Remember, your fingernail could break this, so we want to just be careful. And then okay, so there is our egg. Something we could write down in the anything else is, remember, what color was that liquid around the egg? You noticed it was purple, right, when we dumped that out? But why is it purple when the corn syrup wasn't purple? Why is our egg purple when I can guarantee you if I go crack open an egg, we're not going to see a purple egg? So what's going on? Let's jot down those observations. So liquid around the egg was purple. The eggs inside is purple. So what is happening? Remember, 2 days ago, we put our egg in colored water, right? And that water, based on my little picture here, went into the hypertonic egg compared to the hypotonic outside. Remember, hyper means it has the higher concentration. Hypo means it has the lower concentration. So that water went into the egg, but the water was colored. So the colored water went into the egg. So this just helps to prove that water went into the egg because it was colored. We kind of gave it like a a little extra test just to make sure that happened. So when the water left the egg into the corn syrup, the color came with the water and came out and tried to dissolve the corn syrup because the corn syrup became hypertonic to our hypotonic egg. Now, it depends, like the hypo and hyper, it can switch. It's just relative to another solution. So whichever one is more concentrated than the other becomes the hypertonic. Whichever one is less concentrated becomes the hypotonic. For the egg and the corn syrup was very concentrated. I mean, it's like pure sugar and water, basically. The egg was mostly, water with all its other parts, but because it was hypotonic, that left. So we can write this down. Water left the egg because the egg was hypotonic to the corn syrup. And if you're someone who likes to have a little drawing here, you can totally do that. So water, corn. So the water left our egg because this is hypertonic. Okay, so kind of just a little, if you need a little bit extra there. So we're going to go to the back side and finish that up, or I'm going to give you a few little helpers to get started there. But, well, we still have our egg. Is anyone sitting there wondering, what does the yolk look like? Right? Like we can see the water, we can see the egg, we can see that there's more water than the egg white because everything's still kind of together. But what about that egg yolk? Now, remember, you can have things within the cell that also kind of have a little bit of like a membrane or like a protectant on them to make up each of their cell organelles. Remember, the yolk is basically a nucleus of the egg. So, if I can get this too. So, that membrane, it was trying to dissolve the egg white before the egg yolk. So the egg yolk is actually still yellow because it didn't quite get into that part of the membrane. So kind of fun there. Now I'm going to wash my hands for like the 15th time today. And let's look at some little helpers on the back side to look at this and kind of help make sense of what is osmosis, because that is what the point of this lab was. It wasn't just to see how cool the egg would look by adding different things. It was to see osmosis. So remember, we did this, was it day 2, I think? Osmosis is when a liquid, in our case water, is passing through a membrane. It's a type of passive transport, meaning that there's no energy required. It's going to do this regardless if there's energy or not energy. It does it by itself. So you noticed your cup at home or my cup here, I didn't have it plugged into an electrical outlet. It just did its thing. So our hypotonic meant that it was a low concentration. The hypertonic means that there's a high concentration. So in these pictures below, we're looking where there's a hypertonic and hypotonic areas and use arrows to show which way the water is moving. For the one that's reached equilibrium, write the term isotonic. So isotonic basically just means that it is the same inside and outside. It's kind of referring to we've reached equilibrium. So when we look at this first one,